Lesson 2. Hey, Mr. Dewick, what happened to Lesson 1? I skipped it temporarily. I wasn't happy with starting Lesson 1 in the order that they did things, so I may bring back Lesson 1 about 3 or 4 lessons from now. Lesson 1 was jumping right into these complicated word problem-y things, and I think it's better to go from the abstract and then deal with word problems. So, Lesson 2, solving a system of linear equations graphically. By the end of this lesson, you'll know what that phrase means. We are going to start out with a word problem, but then we're going to move into generic stuff. It says this: the Jones family and the Pearson family are going to a book fair raising money for cancer research. Mr. Jones pays entry fees of $11 for 3 adults and 1 child. Mrs. Pearson pays entry fees of $12 for 2 adults and 3 children. And then it says, we can determine the cost of an adult ticket and a child ticket by forming 2 linear equations and graphing them. First of all, I hate word problems like this. They're stupid. I would suggest, Jordan, that if you've just paid the entry fees, you know how much you paid for an adult and how much you paid for a kid. And this is dumb. And I agree with that. However, I will say systems of equations, the unit that we're looking at, they do make word problems much nicer later on. So I'll tolerate this, I'll call it a stupid, contrived question for now. There are 2 types of tickets. What are the 2 types of tickets? Read the question. What are the 2 types of tickets? Adult and child. You know what? We're going to let X be the price for an adult What would be a good letter to use for the price of a child? Because I asked you to. What would be, yeah. Y be the price for a child. And that means we can actually write an equation out of this. I'm telling you, we can. Nathan, can you start reading? Nate, can you start reading for me the second sentence, starting with the word Mr.
Mr. Jones paid entry fees of $11 for 3 adults.
Stop. Instead of adults, what letter are we going to use? What letter are we going to? So how would you write 3 adults? 3x. Katie, what's the word that came after adults? So $11 for 3 adults. What's the next word? No, you missed the key word. And. What mathematical operation does and mean? Plus. Now, Katie, the next phrase. Has everybody got the seating plan already? Look around. Any empty seats on it? I'll let you figure it out. What's the next phrase that you read? How would I write 1 child? What? Yep. Hey, how much money was that according to that first sentence? Well, the second sentence, the middle sentence that I had Nathan read. $11. That there is a linear equation. How can I tell it's linear? How can I tell that if I graphed that, it would be a line? If it had curves, if it was a curve, what would it have? Yeah, weird stuff. Yeah. Okay. Let's go, Jake, to the last sentence, starting with the word Mrs. Can you read to me, kiddo?
Mrs. Pearson paid entry fees of $12.
Okay, you know what? I think it's going to be $12. Yes?
Yep. For 2 adults.
How could I write 2 adults?
2 adults.
And then what does the word and mean? How could I write 3 children? Okay. Now, some of you may do this intuitively. We used to, in the old curriculum, do a huge unit on word problems in Math 9. And Curtis, I would actually teach kids how to rip apart each sentence like that. In fact, I would actually teach them to read the sentence backwards. I would teach my students to read, so the sentence I had you read, Nate, Mr. Jones pays entry. My students would have read 1 child, X, and plus 3 adults, 3x, or sorry, y for one child, 3x, for $11, equals $11, and you can actually get the whole equation that way. Math and English are written backwards, and so I said, well, just read it phrase by phrase backwards. They got pretty good at it. Systems helps us get an equation, I think, much nicer. Here's what I want to do. Oh, this is also a linear equation, the second one, Mac, because no funky exponents or anything like that. I want to find the x and the y that satisfy both of these at the same time. Let me give you an example. There are some numbers that work in this first equation. If I put a 4 right there, what's 3 times 4? 12. Y would be -1, because then I would get 12 plus -1 is 11. That works. The point 4, comma, -1 is on that graph. In English, that doesn't make sense, because how can you have -1 kids? But in terms of a graph, that works. In fact, I could put a 5 in for x, because what's 3 times 5? 15. Y would be -4. 5, comma, -4 is a point on that graph. And there's an infinite number of points. Hale and I could keep finding more and more and more and more, because the domain of this is all reals, and the range of this is all reals. Oh, and I can find points that fit in this equation here as well. For example, I could go, let me find one that works out nice. I could put a 4 right there. What's 3 times 4? 12. A -1 in for x, because I would get -2 plus 12. Sorry. A 0 in for x, I would get -0 plus 12 equals 12. So 0, comma, 4 is a point on this graph. What I want to find, when I say solve a system, what I'm really saying is, can you find the x and the y that work in both equations at the same time? And there is a way to do it. The first way, the least efficient way, Rob, but the way we always start out, is to say, you know what? We can graph each of these. And the x and y that satisfy both of these equations will be where these two graphs do what? Cross. Fancy word, intersect. Show you what I mean. It says, draw the graphs of the equation. Here, pen. 3x plus y equals 11, and 2x plus 3y equals 12 on the grid below. I think first of all we're going to have to change them into slope-intercept form. Since there's two equations, I'll draw a line down the middle. I'll do the first equation on the left. How would I rewrite this first equation into slope-intercept form? How would I get the y by itself? You just wrote a test on this. How would I get the y by itself here? Minus 3x. In fact, I think it's going to be y equals -3x plus 11. How would I get the rewrite the second equation? The second equation. Well, I think I would minus the 2x over, and I would get -2x plus 12. And then how would I get the y by itself here? Divide by 3. Divide by 3, divide by 3. The second equation is going to be y equals -2/3 x plus 4. This second one we can graph fairly easily. We're going to graph this second one first. What's the y-intercept of this second graph? 4. That means count 1, 2, 3, 4 up. What's the slope of this second graph? Down 2 over 3. Down 2 over 3. And I can back count and up 2, back count. It's going to look like this. This first point, this first graph, is a bit of a problem, though, because what's the y-intercept of the first graph? Have I got 11 squares? Yeesh. You know what, though? I don't know if you remember, the very, very first way we learned to graph was with a table of values. So I'm going to try sticking in some x's and see if I can get 2 or 3 y values that will fit on my graph. So I'll try, how about when x equals 1? Put a 1, substitute a 1 in for the x. I'll have negative 3 times 1 plus 11 equals y. When x is negative 1, what's the y that goes with it? I'm not going to do it for you. So put a 1 right there. What's negative 3 times 1? Plus 11? Oh, when x is 1, y is 8? That's a point on the graph. Does that fit on my graph paper? It does? 1, 2, 3, 4, 5, 6, 7. It barely does, but it does. Let's try putting a 2 in. Negative 3 times 2 plus 11. What y value goes with x equals 2? Rob? 5? Saw your lips move, you were right. 2, 1, 2, 3, 4, 5. Let's do one more. How about 3? Negative 3 times 3, 9. Negative 9, sorry. Plus 11, 2. It looks like this graph, oh, you know what? I could have actually just found the first point and gone with the slope, because what's the slope of this graph? From the equation, what's the slope? Negative 3, which means count down 3 over 1. Once I had that first point, 1, 8, if I'd been really clever, I could have just gone down 3 over 1, down 3 over 1, because it would work from there too, not just from the y-intercept. So I'll keep going down 3 over 1, down 3 over 1, down 3 over 1. As a line, it looks like that. And you'll notice, Rachel, these two lines intersect at a point. That point is the x and y that satisfy both of these equations. That point, Sarah, is the solution to this system of linear equations. What is that point, Sarah, my child? What comma what where they cross? Count for me. What over? How many over? How many up? So the x-coordinate is 3, yes? Y-coordinate is 2. What that really means is adults cost children cost. How much did adults cost? What letter did we let be adults? X. What is the x coordinate of this particular solution? Adults cost $3. Children cost $2. Conclusion, adults are worth more than kids. Therefore, we're more important. Well, maybe not. Turn the page. Angela, in my first example, we used that first equation to represent the information for the Jones family. And from the graph, we can see there are many values. For example, we said when x was 0, y was 11. When x was 1, y was 8. When x is 2. There's a whole bunch of different values that satisfy x and y in that equation. We used the following equation, 2x plus 3y equals 12, to represent the information for the Pearson family. From that graph, there was a whole bunch of points that worked. For example, when x was 0, y was 4. When y was 0, x was 6. However, if we consider both of these equations at the same time, there's only one solution. What was the solution? X was 3, y was 2. Those two equations, considered at the same time, are called a linear system of equations. A system of equations is when you have more than one variable and more than one equation. A linear system of equations is when each equation, when you graph it, turns out to be what? A line. Next year, you will learn nonlinear systems in Math 11. You'll find how to find out where two curves cross, or where one curve and one line cross. Here, we're going to start out like this. The solution to this system is x equals 3 and y equals 2. That's because x equals 3 and y equals 2 satisfy each system. So to solve a linear system means to find the x and y that work in both equations, that satisfy both equations. And the first method that we're going to use today, Mickey, is to graph them. It's the worst method, it's the most time-consuming, and it has some flaws that we're going to talk about. But we always start out there because, Brendan, it's nice and visual. Hey, find where lines cross. So the solution is the point of intersection. It's where they cross. And then I wrote in the next sentence, a system of linear equations may have blank, blank, or an blank. I want you to imagine, oh, better yet, I got 2 meter sticks here. Here's 2 linear equations they can cross. Can they ever cross twice? Can I ever get 2 solutions? Can you think of a way? Jordan shook his head right away. Can you think of a way where I could get no solutions? One possibility we're going to find is if they have the same, what would make lines parallel? We learned this last unit. If they have the same, say if you notice that your equations have the same slope, I'm sorry, no solution to this system because they never cross. There is a third possibility. You can have one solution, that's our preferred. No solutions, kind of sucks, but okay. Or you could have an infinite number of solutions because you may graph the first line and you may graph the second line. And when you graph the second line, you find, holy smokes, it overlaps with the first one perfectly. It turned out to be the same equation in disguise, which means it crosses here and here and here and here and here and here and here. And you know what? How many solutions is there if they overlap perfectly? Infinite. There's 3 possibilities for a linear system. And we're going to talk about this more another day. We're going to specifically, I'm going to teach you shortcuts at how you can glance at a system and say, that's got 1, or that's got none, or that's got an infinite number of solutions. But for now, I just want you to realize these 3 possibilities exist. You may have 1 solution, no solutions, or an infinite number of solutions. Today in your homework, I think you're going to find 1 equation ends up with no solutions, never crossing, and it's very obvious because you graphed it, and you'll notice, oh, the rise over the run for both of them is the same. But they have different y-intercepts, so they'll never cross. Example 1. So on this grid, a system of equations has been represented. The system has an integral solution. In other words, it's supposed to cross right there. I had trouble with the graphics, but it's pretty close. What's the solution to that system? What's the x-coordinate? What's the y-coordinate? 3, 0. In fact, as an ordered pair, 3, 0. Now, the problems with the graphing method, Jordan, there are two main problems that we'll look at next class. The first is, what if you have a line and it crosses right there in midair? How the heck can I read that? I mean, I don't know what decimal that is. That's going to be problem number one. Problem number two, what if you're solving a system and the solution is 3,192, 43,647? Do you really want to count that many squares? I mean, you could be done in a year or two. So we're going to move, Rob, from the graphical method to solve, and we're going to go to next class two algebraic methods to solve. And in fact, I think it's useful enough if you ask me to list the top 5 things that I teach you all year long. Trig, next unit, and you've done some of it in grade 9, but trig, graphing, straight line, slope-intercept form, and using systems, specifically the substitution method next class, because you use it all the time in chem and physics next year. Example 2, graph the following system, turn the page. Graph the following system of equations on the graph below. What was the system of equations, Mac? More than one variable, more than one equation. In fact, there's a rule. How many variables are there in these two equations? How many different letters do you see? 2. How many equations did I give you? 2. You need 2 to find 2. Next year, you may look at 3 variables. Take a guess how many equations you need to solve 3 variables. 3. 4 variables. Take a guess how many you need. 4. 5 variables you need. And in fact, anything more than 3, you tend to go to a computer and use a matrix and have it solve it for you because it's a lot of work. In fact, just doing 3 variables ends up being about a page per question, and you find out why when computers went from 2-dimensional graphics to 3-dimensional graphics, which require 3 variables, you had to get the extra video cards with the extra memory because you just need a lot more memory to do it. Anyhow, that's an aside. Hey, let's graph these. Let's find where they cross. This first one, 2x plus y equals 2. I can rewrite that in slope-intercept. You know what? I'm going to call this equation 1, and I'm going to call this equation 2. I'll do the first one in blue, the second one in black. How could I rewrite that first equation in slope-intercept form? Yeah, that's what I'm asking. More specific. So equation 1 is just going to be what? Y equals negative 2x plus 2. Ty, my friend, what's the y-intercept of this equation? And what's the slope? So put a dot right here, now that you got your head up, and go down 2, over 1, down 2, over 1, down 2, over 1, down 2, over 1. And connect them. Let's rewrite equation 2. I guess the first thing that I guess I would minus x from both sides, and I'll get negative 3y equals a negative x plus 15. Grayson, have I got the y by itself yet? No, how would I get the y by itself, kiddo? I totally agree. Y equals, it's going to be a negative divided by a negative, yes? 1/3 x, and then a minus 5, I think. Yeah, thumbs up. Grayson, my child, what's the y-intercept of this graph? 1, 2, 3, 4, 5. Right there. And what is the slope, oh pray tell? Which means count how? Up 1 over 3. I can see where they cross, can't I? I'll do a few more points just to make it look pretty. But it's clear to me, there's my solution point. There's my intersection point. There's where they cross. So, part A says, hey, what's the solution to this system? I can do that. What, comma, what? 3, comma, -4? I agree. Then it says, verify the solution algebraically. What that means is if I go to the first equation, and I always tend to go to the typewritten one that they gave me, because I might have made a mistake in rewriting it, so I might be checking it in the wrong, in a mistake. I'll go to the typewritten one that they gave me. Wherever I see an x, I can replace it with a 3. Wherever I see a y, I can replace it with a -4. So in this first equation, 2x plus y equals 2. 2x plus y. When I hit enter, what should this equal? 2. If it doesn't, I've screwed up. Am I right on the first equation? Woohoo! Let's check the second one. Second one is x minus 3. X is 3. So x minus 3y. There's x minus 3y. What should this one work out to, Jacob? 15. Does it? Am I right? Have I just given you a way you can check your answers very, very quickly, assuming you bought a half-decent calculator after my entire 3/4 of a year of ranting and raving and bugging? Yeah. This is one of those tests. You don't hand it in early. You can go back and you can check your answers really, really quick. So, verify the solution algebraically. Yay. Example 3. Graph that, solve that. Stop. Shortcuts. Kirkland, are you okay at doing some basic math in your head? Yeah? Can you read to me the first equation? I could rewrite that in slope-intercept form. I could. And there's nothing wrong with that. But do me a favor again. Read to me that first equation again. Something plus something equals 8. Can you give me 2 numbers that add to 8 in your head, please? That's a point on this graph. I can probably get that without actually doing any math. Give me another 2 numbers that add to 8. 1, 2, 3, 4, 5, 6. 1, 2. I agree. Give me 2 more numbers that add to 8. 1, 1, 2, 3, 4, 5, 6, 7. Keep going. 3, 1, 2, 3, 4, 5. This one is easy enough that I think I would have no problem, Halen, if you could glance at that and just start sticking in numbers. You can find X's and Y's in your head that work. Guanting, can you put it on block A for me? Thank you. You know what? I'm pretty sure, Kirkland, it looks like it's doing this. And if you were to rewrite it in slope-intercept form, you would find it has a slope of -1 and a y-intercept of +8. But generally, if they give me an equation with no coefficients, Mac, I can almost always just find the points in my head. In fact, even if they give me an equation with really, really simple coefficients, Ty, I can sometimes just find the x's and y's that work in my head. The second equation isn't quite as easy. If I had to, 5, 1 I know works. No, it doesn't. Never mind. You know what? I'm going to rewrite the second equation in slope-intercept form. So let's take equation number 2. Let's do that without actually covering it up. So here's equation number 2. I already did equation number 1 in blue. Getting the y by itself, you'll have -2x equals, good gosh, let's try this again. -2y equals -3x plus 14. I think you'll get y equals 3/2x minus 7. Double check me, yes? Cole, I'm good? Cole, what's the y-intercept? 1, 2, 3, 4, 5, 6, 7. ¿Qué es del slope?
3/2.
Which means count how?
3/2.
Dunk. Dunk. Woohoo! Dunk. Dunk. State the solution, it says. What is the solution to this system of equations? 6, 2. Then it says verify. It works in the first one because 6 plus 2 is 8. Does it work in the second one? You know what? Let's see if we can do it in our head. 3 times 6. 18. 2 times 2. 18 take away 4. Woo! Works. Rachel, when it says verify, if you want to show all the steps, I'm okay, but I will accept if you're able to do the math in your head and you indicate that by just putting a little check mark next to it, I will assume, Sarah, that what you just did is you did it in your head and you double checked to make sure it worked. Now that means, I guess, if you're really a meathead, you can just put a check mark and skip it. Go ahead. I guess I won't catch you until you bomb on the test. Did I mention this class has a group of kids that just don't do the homework conscientiously? And anyways. Try example 4 on your own. I'll do it up here. See if we get the same thing. So, Logan, try example 4 on your own, my friend. So no need to look over at Jack and smile. Yeah, that first one I got to rewrite. I might be wrong. I did it in a hurry. Did I read the point wrong? People are staring. No. I think I'm right. It worked when I verified. You get 6 take away 3 equals 3 on the top, and you get 3 minus 1 equals 4 in the second one. Yeah, it works, I think. Am I right? I am right. You got 8 minus 4. What do you mean? Oh, 8 comma negative 4?
Yeah.
So check your line. Which one of your lines doesn't match my line?
The second one.
Okay, the second one, by the way, I did that one in my head. Can you read me the second equation?
X minus y equals 4.
Something take away something equals 4. 5 take away 1. 6 take away 2, 7 take away 3, and then I just started connecting the dots. Because that was, are there any actual coefficients in front of the x and the y there? And I'm going to argue, I can probably safely do that one in my head. Otherwise, though, you would minus the x over, but then you'd have to divide everything by negative 1. So you'll get a positive x take away 4.
But isn't, if it's a negative slope, is it supposed to be facing this way?
It's not a negative slope.
It's positive?
Ready? So I.
Y equals negative 2 over 3 plus 1.
That's a negative, this is a negative slope.
Yeah.
That's that one.
Oh.
That's why I labeled it in blue.
But,
That's why I put a little 2 here and a little 2 here. To
Oh, okay.
okay? Because the second one, when you rewrite it, you'll get negative y equals negative x plus 4, and you got to divide by negative 1, so you'll get y equals positive x minus 4, which I'm pretty sure is what I drew there too, a y-intercept of negative 4, and then up 1 over 1, up 1 over 1. Now, Mickey, here's the problem. If you didn't get good at graphing last unit, how do you think you're going to do on this stuff? At least on this subtopic. Now, when I start doing it algebraically, you might say, woohoo! But I am going to ask you on your test to solve some of these graphically. Is it 3, negative 1, folks? Okay, I'll ask. How many of you got that first time? So we need to practice this a little bit. Did I do a little speech before I started my lesson about it was very easy to make sloppy mistakes in this stuff? Yeah, I did? Oh, good for me. Math 11, preview of coming attractions. Coming soon to a math class near you. Coming this fall. Math 11. How can I tell just by glancing at this that this is a nonlinear system? There's a curve, squared. The first one I can graph very easily. Y equals x plus 2. I'll graph that in black. I'll call it equation 1. I'm sure that has a y-intercept of 2, and it goes up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. I got it, Mr. Dewick. Yeah, I know, but I like saying it. Up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. This second one, you may recall, we actually gave this graph a name. It was a parabola. And we graphed it by doing a table of values. And what I mean by that is, well, when x is negative 3, when I put a negative 3 in for the x and then I go negative 3 squared equals y, what's y? 9. Does that fit on my graph? 1, 2, 3, 4, 5, 6, 7, 8, 9. 3, 6, 9. Yep. What about when x is negative 2? 4. Negative 2, 1, 2, 3, 4. What about when x is negative 1? What about when x is 0? Let's do a few more. What about when, let's do 1, 2, and 3. What about when x is 1? 1. What about when x is 2? What about when x is 3? 9. So the blue graph looks like that. Hey, how many solutions does this nonlinear system have? 2. 2. What are they? Negative 1, comma 1 and 2, comma 4. So the solution of this system is negative 1, comma 1 and 2, comma 4. Oh, Mr. Dewick, this works great. Why do you need to teach us any other methods? Because if those were decimals, you couldn't read them from the graph. What if it crosses at negative 1.832, which could happen? I could come up with an equation that has that as a solution. How would you read that from the graph? And the answer is you couldn't. Or what if it crosses at 45,219, 39,417? Who wants to count that much? But for now, we're going to start out by saying, how can we solve a system? By graphing. I have 2 handouts for you for homework.